Today I came up with a new sum which is next permutations. So let's dive into the sum and I will explain both the approach as well as the code implementation. So in the sum they are given an integer array which represents the any one of the permutations, and we need to implement the next permutations which rearrange the numbers in lexicographically largest greater number. And if no such permutations exist means we need to return the lowest possible order, that is ascending order. For example, if all the elements in the given array is reversed, totally reversed, and what will be the next possible lexicographically largest permutation, which is the ascending order of that particular array, right? So that's what they are given, and these are the examples of this particular sum. Mm, this approach so that you will get an idea of how to face this sum. So, first of all, what does mean by permutations of a particular number? Permutations means the possible ways to arrange a particular elements. So, for example, it depends upon the type of depends upon it, and it varies from different array. Like if an array contains three elements, then the permutations, total number of permutations will be 3 factorial. And if the size of an array is 4, then the total number of permutations will be 4 factorial. And everything is depends upon the size of the element, size of the array. Mm, And so these are the algorithms which we are going to use for to find the next permutations array for the given particular permutation array. So the first thing we need to do is to find the pivot element from the rightmost element, that is from the reverse. We need to find the element which is smaller. What can I say? Yes. Yes, let's take this as an example. Oh, wait a minute. Take this as an example. Yes. Let's take the element as, so let's take 1, 2, 3, 6, and 5 as the array. And we need to, the first step in this algorithm is we need to find the first pair from the right where the order is increasing. So we need to iterate, we need to find the pivot element from the reverse order. That's the first point they are telling. So 4 is less than 5. That is 4 is greater than 5. Yes, it's true. It satisfies the condition. And 5 is less than 6. This is also true. And this is not the pivot element. We need to find the first decreasing element from the reverse order, which gives the pivot element. And that is the first step to find the next permutations of the given array. And 3 is less than 6. So this doesn't satisfy the condition. So the first decreasing element in the reverse order of this array is 3, and 3 will be the pivot element. This is very important step of finding the pivot element. So in this given array, I forgot to take screenshot of that input array. So this is the input array 1, 3, 1, 2, 3, 6, 5, 4. And so here 3 is less than 6. So the index is found at 3. So the pivot element is 3. What will be the index? This is 0, this is 1, this is 2, 3, 4, 5. So the index is 2. And then second step is, after finding the pivot element, we need to find the smallest element to the right of 3 that's greater than 3. So we need to find the smallest element which is greater than 3. That is first greatest element after 3. Got it? So let's take this as the pivot element. And we need to consider the elements after the pivot elements only. Don't consider the elements before it, that is 1 and 2. So let's focus 6, 5, and then 4. So the next permutations obviously will be the greatest element of the 3. That will denote the next permutations element, right? So here, after the pivot element, 6, 5, 4, all are greater than 3. But we need the smallest element which is greater than it. So how can we find this? We need to iterate through all the elements and find the smallest greater element. So 6 is greater, but it is larger, it is too much bigger than, and 5 is also greater, and 4 is also greater. So here all these three elements, 4 is the smallest one. So we take this as the smallest greater integer of the three, and we need to swap the pivot element with that greater element in order to find the permutation value. So in next step, we will get 1, 2, 4, 6, 5, and 3. Here the positions of 3 and 4 are get interchanged. And the next step is we need to reverse that part which is swapped, which is the swapped element. So now the pivot element becomes 4. We need to swap all the elements after that pivot element. That is 6, 5, 3. We need to reverse them, which will give the ascending order of that elements, that is 3, 5, and 6. In all the arrays, the reversing the elements after the swapping will definitely gives the ascending order of that element. Why? Because here we are swapping 3 with the largest element of that. So 4 is swapped in the position of 3. So obviously after so obviously mm, wait a minute. I will explain this with an example. Why instead of sorting, we are reversing this element, which will gives the ascending order. So let's take this example 3, 6. Instead of 5, we take 4 and 5. Here you can see that all, even though we are interchanging the positions, all the elements are greater than 3. And we need to swap 3 with the 4. So 4, 6, 3, and then 5. So this will not definitely give the ascending order, right? Let's take another example. Instead of 5, 2, and after the pivot element 6, 4, and then 2. Uh, Here also we need to swap 3 with the 4. After swapping, we will get 4, 4, 6, 3, and 2. Here you can see that after swapping, what is the next step? We need to reverse these elements, right? After the swapped element. So if we reverse this element, what we'll get? 2, 3, and 6, which is same as if we do sort the elements after the swapping, right? So how it works because first we will compare 3 with the last element 2. So 2 is less than 3. So obviously if we reverse the elements after the swapped elements, definitely 2 will comes first element, and 3 is less than 4, and 4 is the next largest element. So if we swap 4 with 3, obviously 3 is again greater than the next previous element 2. So if 3 is greater than the next previous element 2, then it will be smaller than the before element 6. That's the logic they are using here. And after reversing that part, we will get the final next permutation value. So this is the final answer. Here, what does mean by lexicographical? So it means we need to return the order of that permutation, sorry, order of that array in the dictionary order. That is in the alphabetical order. And so these are the permutations of that element. So consider the array 1, 2, 3. So the next permutations will be 1, 3, 2. So 3 and 2 are reversed. And next one is we consider 2 as the first element, 2, 1, 3, and interchange 1 and 3. So 2, 3, 1, and 2, same repeat with 3. So here the number of elements in this given array is 3. So 3 factorial is, so 3 factorial is 6, and we have got 6 permutations. Here the 6 permutations. So if they are given an input as 2, 1, 3, then the next output will be 2, 3, 1. Why? Because we need to implement these 3 algorithms. What means? So the step 1 is that, what is the step 1? Can you remember? We need to find the pivot value. I simply write pivot. So then what is the next step? After finding the pivot value, we need to find the largest element than the pivot, which is the smallest largest element than the pivot element. Largest element. So after finding the largest element, what we need to do? We need to swap and reverse. So let's try with this example and we will get the next. So if the input array is third permutation, then we will definitely get the fourth permutations as they are asking the lexicographically next permutations. So the input is 3, sorry. So the input is 2, 1 and 3, and we will get the next permutations as 3, 2, 3, 1. So here what is the pivot elements? We need to start from the end. We need to find the pivot element. So 3 is greater than 1. So 1 is less than 3. It doesn't satisfy the conditions. So the 1 is the pivot element here. So after finding the pivot elements, only concentrate on the after elements, that is the elements after the pivot, which is 3. There is only one element, which is 3 and 1. So what is the second step? We need to find the largest element. So obviously there is one element and 3 is greater than 1. We need to swap it. Swap both elements. So it becomes 3 and 1. And after 3, there is only one element. Even though if we reverse it, we will get again 1. And the final answer is 2, 3, 1, which is the next lexicographically largest permutation. This is how it works. Here you can see the example again. So 6, 5, 4. So what will be the permutations? 5 is greater than 4 and 6 is greater than 5 and 3 is less than 6. So here 3 again permutations, and after that we need to find the smallest largest element. Here 4 is the largest element. After 3 we need to swap 4 and 3, and after swapping we need to reverse the elements after the swapped element, that is pivot value. So the 653 becomes 356 and this will be the final output. Now let's see the code implementation for this algorithm. So they are given void function, so we don't need to return anything. Just simply apply the algorithm techniques here. First, we are taken size of the array as n, and I is equal to n minus 2, because if we take an I is equal to n minus 2, so in this, what will be the value of n here? So 0, 1, 2, 3, 4, 5, 6, 6. So 6 minus 2 is 4. So here we taken 4, and I plus 1 becomes 5. Obviously, I plus 1 is the last element, right? And every time we are getting array of I is greater than, so this is array of I. So in this 5 is array of I, and this is array of I plus 1. So 5 is greater than 0. Every time we are getting the greatest element, that is array of I is greater than or equal to array of I plus 1, we need to move from the right to the left until we find the pivot element. So here 0 is, 5 is greater than 0. So we need to move to 7, and 7 is greater than 5. So we need to move to 1, and 1 is less than 7. So the pivot element here is 1, and here the loop will get stopped. And what is the I value here? So I is equal to 0, 1, 2. So the I is 2. So 2 is obviously greater than or equal to 0. And why we are taking here, why we are checking here whether the I is greater than or equal to 0, I will tell you later. And we need to take another element, J is equal to n minus 1, which is the last element. And we need to, after the pivot element, we will only concentrate on the after elements of the pivot. And we need to check from the last element till the element before the pivot. So start with 0. Uh, but array of I is 1, array of j is equal to 0. So 1 is greater than or equal to 0. That is, it is smaller than the pivot element. So we need to move from right. We need to decrement the j value, and it becomes 5. And 5 is greater than 1. So we need to swap 1 with 5. It becomes, so the positions of 1 and 5 are interchanged here. And after interchanging it, we need to reverse the element. That is, reverse the element after the, sorry, we need to reverse the element after the pivot element till the end. And that's how it returns the value. So if it checks all the elements in the array, and nothing is lesser than the previous element, so consider this example. So 1 is, 2 is greater than 1, and 3 is greater than 2. So the I reaches minus 1. So in this 3 is greater than 2, then I gets decrement to 0 to minus 1. When I is equal to minus 1, this loop, while loop will get stopped, and it will enter this loop. So if I is less than minus 1, this condition also doesn't work, and it directly goes to this line where it will reverse the whole array and gives the ascending order of that element as given mentioned in the question. If no such permutations exist, we can return the array in ascending order. So no such permutation exists in this input sum, and we need to return the I by. So here we having I plus 1. So here I is equal to, obviously if this condition doesn't satisfy, then I's value will definitely be minus 1. If I is minus 1, this will becomes minus 1 plus 1 is 0. Then, and it will reverse the element from the beginning till the end, which will give the ascending order of that particular array. And that's how it works. So I hope you all understand. Please, if you like it, please share it, subscribe my channel, and do like my videos. Bye bye. See you next video.